I will be explaining the way I have envisioned to store the blockchain data. So the data storage, the green one here, will be dedicated to storing the actual chain data. The relational database will store the actual transaction details so we can quickly look them up without scanning the whole chain to look for maybe a really old transaction. The storage method I will be explaining on this video is the local storage. I will be writing each block into an individual file, and the file name will be the actual string of the hash for that block. And I will also be writing the metadata into a different file. This metadata will be general information like how many blocks have been mined in the blockchain and the last block, that is for the hash of the last block, so we can start scanning from that one and go back to the first one when we're loading the data. Here is the binary data spec for each of the blocks. As you can see, I will be storing this in a binary format so it can be loaded quickly. The storage version is, let's just say I change a format in the future, I might want to up that version and add backwards compatibility. The rest of the things are pretty self-explanatory on how the file will be written. The manifest variables I will start out with are the last block hash, which is the binary representation digest of a block. The second one will be the string representation, this one here, and the block count, the total number of blocks will be. So the new files that have been added are here in the storage directory. I also made a new namespace called storage inside the blockchain namespace. So I'll begin explaining the iStorage interface. This interface's purpose is so that if I want to add other storage methods in the future, I can just implement this interface into the new storage methods. Now this function here, this is called when the chain is initialized. So it basically will scan the data and load the chain into memory. This one here loads each individual block. It uses the hash inside the actual pointer object and then loads the rest of the data in it. And this one here is to save the block data, so it generates a new file and updates the metadata. And dispose is basically to dispose the actual object that is using this interface. This enum here, the eStorage type, is where I will be adding any storage types. This last one here is just a counter. This is not a real storage type. But the current storage types are none, which means there's no storage, meaning the blockchain will die once you kill the process. And local means it will use a local storage, which is the one I will be explaining. So here is the local storage class. This is a version. Basically, this means if I ever change the format of the storage, I would want to change this version. The mbase path is the directory where the files will be written. The mchunk size is, I will be reading the files in chunks if they are too big, so I will be using that as a chunk size. And the metadata is what's being loaded from the actual metadata file, which is the additional file. Now here you can see I implemented the interface functions and I also added a few more. Now I will start with the constructor of the local storage. Here I just check if the directory exists. So if the directory does not exist, I will create the directory. And then once the object is created, I will attempt to load the metadata. So I will go now to the metadata one that is here. So this just grabs whatever directory the data is being stored and opens the actual metadata file just called metadata. Here is the regular C++ opening function. And here is where I read the content of the file. Now this is binary reading. Basic C++ knowledge should get you through this section of the code. Basically, I'm reading the format I described on the PowerPoint. Now here are a few functions I added to cchain. This is the load. This means it will load the chain from whatever storage is being used. A function to return the number of blocks on this chain, and another function to check if the chain is valid. This basically goes through all the blocks and makes sure they are valid. Now you can see I added a new parameter to the constructor, which is the storage type, and I initialized that storage. So basically what that does is, this is the regular create storage function that returns the interface, and depending on the type, it will either create the local storage class or the none, which is basically just an empty storage that does nothing. Now I call the new function called load, which is on the C chain, and this is what attempts to load the chain from whatever storage is currently instanced. Then if it successfully loads the chain, it will set the current block to the last one in the chain. And if the size is above one, meaning it actually did load a chain, then it goes to the next block, because the next block is the one we will be actually writing data. The last block in the chain that was loaded from the data, from the storage I mean, is already finalized, so it can't be touched. So it just goes to the next one. Now this function checks for the validity of the chain after it's loaded, or whenever you want to use it. It just grabs the current block, which is the one that we're working on. We don't want to check the validity on that one, so we go directly to the previous one, and then we call the isValid function. Now that's a new function that was added to the C block, and this function, what it does is calls the calculate hash, and instead of having calculate hash right to the hash that is on the object, if you pass this property, it will write to that one instead. So here we allocate a hash, we set it to 0, we calculate hash, then we compare the hash that is right now calculated with the hash that's on the object. Now when will this differ? The only way this will not be valid if it's someone modified the actual storage file. So this basically checks as your chain is valid and then touched. Now here, every time next block is called, and it's not, except for this one, it is the old block that is already finished is saved. So this is what calls whatever storage interface and calls save. Now here I will explain how it's saved. So I send the actual block object and the current block count. That's just change it into metadata once it saves the metadata, because it saves the metadata every time a new block is finished. And then I write the binary file in the format I already explained. Here are the other two metadata variables on the map that when save metadata is called, basically writes those metadata variables to the metadata file. Now I added a few new things to test on this main. I added to check if the chain is valid, and then I added how many blocks are when I load the chain and how many blocks are at the end of the chain. I also added an iterator that goes through all the chain and then lists out the blocks. So let's run it now. So let's go to build and make. Let me make sure I delete if there's any previous data. So this is the first time I called the blockchain. So it created 2 blocks. So it has 3 block count, but this includes the working block, meaning the block that hasn't been saved. So here are the 2 saved blocks. I'm gonna add 2 more. So now this means we have actual persistent storage for our chain. It's loading the previous data and adding the new data, the D2 blocks. So this is successfully working. On the next video, I will be explaining how to network various nodes of the blockchain. So remember to subscribe and comment. Thank you.